Okay, so we'll start.
Yeah.
Okay, so Thereshil, you're there, right? Because I added you as the code reviewer. So we'll go through code review.
Yeah.
Yeah, okay. Let me increase the screen. Okay, so then you were at.
Should I approve or?
We'll do the review first, then you approve. Not right away. Where is? Oh, sorry. So currently, no, not this one. Yeah, okay. So this one is currently in review, and what we had previously was, let's see, after you have had a break of 1 hour and you forgot what the last state of the code was, usually we go to the branch, see what the code is doing. So this is what the new thing is. Right. Okay. So, and this is the code that has been committed to the branch, which is called 1. So the fun thing is, this is branch 1, but the issue which is open, what is the merge request called? Oh, it's called by the last commit name itself. Fine, because we have been keeping this branch alive. So the branch name is already taken by one of the issues, I think. Yeah, one of the merge requests. So the following merge requests will be named after the comment, last comment itself. So that is fine. Now, essentially code review will be where a bunch of people, usually they are senior developers or something like that, who have some experience in writing code, making a lot of mistakes, right? Like coding in a lot of bugs and then trying to figure out what bugs are there. Then style, syntax, good coding practices, data structures, designs, algorithms, and all this. Have some knowledge. They will comment on the beauty or the hideousness of the code that you've written, and then they will suggest changes. So usually what you do is, after you have issued a merge request, a code reviewer will usually go to the changes tab and try to see what all has changed in which file. So here you can see that there's only one file right now. It's a very simple code, and what has been deleted and what has been added. So here you can see previously we had this array capital T, and now we have two arrays, and then these things have been changed, and this huge portion has been added. Okay. So now usually code reviews will start by comments coming up here. So for example, one code review might be that isn't okay. This is Harishil should write. So Harishil, let's do this. Like, what would you say is wrong with this code, or what can be done better? Not wrong per se. What can be done better? Let's put a positive spin on it. So if you can just comment anything, or if you don't find anything, it's perfect code, then you can just comment saying that I don't like the name temp or something.
Okay, so right now I don't see the whole. Like right now you see like two.
Okay, yeah. So basically, if you go here, on the gear icon, you can see either inline or side by side. Is that what you're talking about?
No, I just see the this thing only like one. So temporary change. So temp to T. That is the only variable change I see here right now. Okay, but let me.
Yeah. Okay.
Just a sec.
Yeah. So in the meantime, we can explore some of these. So there is one comment.
Yeah, I mean this is the only change that I see. I think you showed much many more.
Yeah, what is the change? Wait, we're just
It's like,
waiting. Okay, wait, I'll stop sharing my screen. Yeah. Is everyone able to see the share screen? I'm not for some reason.
No, I'm not able to see.
Yeah, I can't see.
oh, wait, I'll do it again.
Okay.
Is it visible?
Yeah, no, it's fine. Okay. So you have gone to the conflict resolution. So can you just go back to the merge request again once? So just the merge request tab. Yeah, okay. So here in the changes tab, what are you seeing? Okay, so basically you clicked that merge resolve conflicts part, right?
Yeah, right.
Yeah.
Yeah,
So
here.
before that, so I was in the tab on top. You see overview, comments, changes, like just below the title of the merge request.
So where exactly?
Yeah, overview, comments, changes. These three tabs that are there below. Add update steps.
Sorry, I can't
So
locate
just
it.
at the top, just at the top of the page. So you can see the overview tab, right? Overview 0 at the top.
Oh. Sorry, Somandip, I cannot locate it. So you're saying here or
Here only. Yeah, okay. Just you can see the title of the
okay.
comments
And changes here
changes.
you are
Yeah.
saying?
That
Okay,
changes.
sorry. Yeah.
That changes tab. So that is where I was at. Okay.
Okay, fine.
So okay, fine. Then I'll switch to my sharing. Right.
Okay.
Okay. So we are at changes right now, and you can start commenting on the changes. For example, like if you want to comment from lines 7 and onwards, say ki, I don't like this variable name. Change it to some t, and you can add the comment. So so this is a reviewer's comment. Okay. Suppose here also, and I say that why did it come here? So yeah. So bulk temperature better not be 0 because 0 Kelvin is impossible or something like that. So you can keep adding random comments. Okay. So you can go ahead add any comments that you want. So usually once the reviewer has added a comment like this, so I'll just refresh my page. So just let us know when you have added some comment like this somewhere. It may not even make sense. Just you can write anything you want. So the idea is you can start a discussion thread on this comment. Now, suppose this is an actionable item. Okay, 0 Kelvin doesn't make sense much. So I'll say, okay, boss. 0 doing change or something. Okay. So you add the comment, and then what you do is you can create a new issue out of this comment thread. Okay, so let's do that. So title would be follow from update steps, something non-zero t. Okay, and so on. Keep the usual things. And here it says creating this issue will resolve thread in this thing. So basically, it will create an issue, and once you close the issue by merging it, it will automatically close that thread also that was going on, the discussion thread. Okay, so there are multiple ways of doing code reviews. So let's quickly do a create issue. So this is just to show you that it's might look very complicated, but it's not. It means basically everything is an issue or a branch, and you create a branch out of every issue. Then you merge request and close the issue. That's it. Okay, so I'll just create a branch. Apart from just directly creating a branch, if you already know that you are going to merge it to main anyway, then you can directly create a merge request and a branch. So basically, then you remember to merge it back. So usually for more exploratory stuff, like more research-oriented stuff, where you are not very sure that the problem you're trying to address by like coding for a particular issue, whether that is actually going to help or not, do you want to even merge it back or not, you can create a branch and leave it there. Later on, we'll see if we want to merge it back or not, and then we'll create a merge request. If the problem statement is very clear and it is very clear to you that you're going to merge back, you can directly open a create merge request and branch. Okay, so it will directly create a merge request and a branch along with it. So this is the branch for follow-up, this thing. And now if I look at the branches, you'll see that there's a new branch that is opened up here. If you look at the graph won't show much right now. So here I'll do a git pull. Take out the new branch locally. It will bring in the new branch locally. And then you do a git checkout to the new branch. Okay. And then the task was to change it to, oh crap. This came out from main. There.
Yeah, Samit, one quick question. Why don't this tab completion doesn't work in Rudra? I mean, I've seen in other clusters also it doesn't work. I don't know.
Because the shell script might not have tab completion. Let's see. Okay, this is very out of the box right now. Sorry. See, so tab completion means two of what? Git.
Yeah, for example.
Okay. No. I understood. This is an issue which is already addressed in. Wait, let's see. Systems. Yeah. Wait, tab completion. Auto completion. So so it says let users decide if they want this feature, they can add to their bash RC. So essentially what you have to add is this thing. Can you just add this? So you can go to this issue and get the link.
Okay.
So basically it's a bash RC change. So since I can't go into everyone's bash RC and do it myself.
Yeah, thanks.
28.
Yeah, I didn't know that I created this. Okay, thanks.
So, okay. So, yeah, what we faced was that we branched out wrongly from main, which doesn't have the new code. So what we'll have to do is we'll have to somehow get the code already in branch 1 into branch 4. So what do you do? Right now, we don't have that. So one simple thing you can do is whatever content is there in 1, you have to push pour into 4. So you can just do a merge. So your new merge request, take 1, take this, and put it into 4. Note that you're not going to close 1. You're just updating the contents of branch 4 using branch 1 because we wrongly branched out from main instead of 1. Okay, so since we're not going to close 1, we'll delete this closest 1 thing, and that's it. And remove this also. Okay, and create merge request. Proof. So now we'll resolve the conflicts, as you can see. 100, 80, which one do you want to keep? We'll use, suppose, theirs, because 80 is the new latest one. Okay, and then we have to merge locally. So again, locally means you do a git pull. This you git checkout to the changes that there's not much change to be done. Then you can again do a git checkout, git pull to update. There's no update here per se, but there's 2 updates. Okay. Git checkout, and this is 4. git pull.
What is that git fetch origin that we are not doing?
We're doing git pull. That's the same thing basically. Git fetch and git pull. Well, there might be a difference between fetch and pull. I don't remember. But yeah, for all purposes, right now it is the same. Yeah. Origin basically means fetch it from the server. See, the other way to fetch things are, suppose you have a .git repo here in thermal.git in your folder. Suppose I copy this thermal and call it thermal new. This is also a Git repo. Okay, I can start fetching and pulling branches from this repo to this repo. So it's not doing a fetch from some remote server. It is going to do it from this repo here. Okay, like a cross within two local repos it can do, and so on. So by default, when you git pull, it will look at the last some stored states. Since we cloned from the remote server or origin this thing, it will by default take from there. If you want to change the location from where you're pulling, I think you can update.
Okay.
Yeah, for local things also. So we'll delete this version of local. Okay, and then right. Yeah. Okay. And we checked out 4. We are already in 4. Yeah, sorry. So we'll just do a git merge from 1 into 4. And you save. So this has been changed. So now, if you look at the code, this should most probably say, I don't know what it say. We have all the things from 1 in this. Okay. So for this thing, now what we do is the main, okay, let's close this. This is done. One thing is, if you really want to see how it has worked out now, push it and see the branch. This will start looking a bit horrible, but okay. You're not afraid of Git anymore. So as you can see, what happened was this one branch was going like this. We just poured the branch 1 contents into branch 4, essentially, here. So that is what the merge is about, and so on. Once you start, drawing some diagrams in using pen and paper, it becomes a bit easy to see how these, streams are flowing into each other and merging with each other and so on. So, okay, now we have our code here. We'll change it to non-zero value of bulk and comment. Okay. So now again, if you look at it has gone up once. So now that we have made the change, we can go back to the code review that we were looking at. So our task first is to finish off this local merge. So mark is ready. It's ready to merge. We'll merge it. Okay. So this is done, right? So this will close by itself. So as you can see, it will say closed. Where does it say closed? It should say closed. No? Why does it not say closed? Okay. So then what happened was we had that issue going on in this thing here as you can see. So we mentioned this change in issue 4 and we resolved those issues and we closed that issue. So this whole code review, which included, so okay, this I didn't work on, but okay. So basically there are permissions which you can set in GitLab, but right now let's not go into the permission details, where you can basically say that unless each and every point is solved, you should not allow people to merge and so on. Okay. So here you can see 2 unresolved threads, and you can again create all the threads in a new issue. It will come as subtasks. So, okay, and so on. So, or you can say that, okay, fine, I don't think this issue is resolved, so you can reopen it again and things like that. So this is how code review in its very rudimentary form works. Usually it takes days and there are a lot of comments and so on. but I think this is best done once you do it interactively in a group. So if you want, we can do a breakout session with groups and practice this. But would you like to do that, or would you like to do it yourself, or with your friends, or with your team, and rather go on to the next topics right now? It's up to you. But I mentioned this because I think next month onwards, this is going to become mandatory for every code because of policies and processes. Okay. So what would you prefer? Okay, you can put in the comments also if you want. Yeah, Maruti, say.
No, now that like, I mean, we kind of understand. So maybe I think we will practice with our team. We can move on. I think.
Fine.
Next.
Yeah, we can go to the next topic.
Okay, fine. Okay, then let's go back to the issues. What all issues are remaining? So, wait, what all have we closed? What all did we do? We add Laplacian had any other things to do? No, nothing. Okay, fine. So as you can see, we have already closed 3 issues, which means we're doing great. And now we'll do this verify reference temperature, but let's see what all is there in the agenda. We'll use that issue for something else, maybe demonstrating something else. Oh, sorry. So code review, so rudimentary form of that is done. A more full-fledged, actually, the best way to do or see how code review is done, there are n number of tutorials on YouTube. If you actually, there are a number of tutorials for any of these things. So if you just go there, and now that you have the basics, if you just go and search for the, you can find other methods which are much nicer. Like here, I made a bit of mess in the merging and all, but there maybe they're not doing live sessions, so they will have a very nice streamlined process overview. Okay, so fine. There was supposed to be a question answer session. Do you have any questions or answers for questions which were asked and I missed? Then we can discuss them, or we can move on to a different topic, which is unit tests. So this is basically Git workflow as a whole. As I was mentioning before, a successful Git branching model. This is one model where okay, let me just quickly discuss the Git branching model once. So now that you have seen how branches work in Git, now for the actual production level code, what would you do? Like suppose someone comes and says, every month end you have to deliver releases with requested feature modifications and updates and bug fixes to the client. So what do you do? So what we follow, at least in SSL as of now, because we looked at different models and thought this is the simpler one, which is not an overkill for an organization of our size. Okay, this is a very clean repo, that's why I don't want to show it. It's not a very good example of how development happens. There'll be a lot of branching out mistakes and so on. So the other live demo code was better. But as you can see here, okay, there is a bit of that here. Okay, there is a red line, which is the main branch, which goes straight like this. And then whenever there is a new feature request, we create a new issue. So for example, there are so many issues which are here. Let me go to the board view, that will be better. Yeah, so there are these board views. And now whenever I would want to, why is this? Okay, let's do it like this only. So the first thing I would do is I'll take an issue, put it in doing, and then I'll create a merge request, or I'll create a branch and merge it later and so on. Once I've created a branch, then you'll see these kind of branch outs happening in the graph. And as you commit and add code, you'll keep increasing this branch little by little. Then when you're done with the addition, you'll merge it back to the main. Now, so basically main contains your latest build. It might, the latest code, it might be unstable, it might have some unverified features. We'll come to that, how to verify features, how to make a minimally consistent code always in main and so on. But basically main is a very latest but unstable version. Now, when you have come across, when you have added a lot of features, like for example, we have milestones here, like this. So for every particular milestone, there are a lot of issues like this which are added to it. And once you have closed all the issues which you planned for a particular milestone, so this milestone went from 1st Jan to May. There's a considerable amount of time, 4 or 5 months. So for 5 months, these many issues were solved. And now you're thinking, oh, this is enough for release. Now the code is sort of well tested, stable. So then what you do is you will go to your, okay, this is the old GitLab repo. That's why it's still called master here. All the new ones are changed to main. But anyway, so you can go to your code here and do what is called a tag release. So you can go to, where is the, hey, where did releases go? This new Git, change the location of everything. Okay, so when you think the code is stable, then you press new release here. The new release will say, okay, what is the name of your release? So usually if you're doing it by version number, it will be 0.80 beta or alpha. There are meanings to these things. It's called semantic versioning. We'll come across it later. Suppose you call it, sorry, let's call it something. Create tag 0.8.0 from what? From master, because that is the latest one, which is current right now stable. Then you can call the release the same title or give some other title and so on. Milestone, you can put a milestone 0.8.0 or whatever would have been there. I think for core in particular, now we are going to a major version shift, so it's 1.00. Okay, and you can put release notes here. So this is where you will bring in your change log. Now I'll show you how to automatically generate a change log from Git commits. So whenever you have generated that, you can copy paste it here, or you can just list down, I fix this bug in, I don't know, advection, speeds up step to STL via something. So you can put a change log of features which you have added here. And then once you're ready to deploy the package or the code that you're going to ship to the client, you can put the URL or the package link and so on if you want, so that you can always refer back to it when you need it. I'll not create a release right now here. So this is what the old releases look like. So for each release, you have a snapshot of the source code as it looked at that moment, and then you have a package URL where the packages are actually available. So for some reason, okay, it's a bit slow, but okay. So here is the tar balls which are there, and the documentation is also here. For some reason, NIS is a bit slow. Okay, yeah, we'll look into that later. Okay, so this is the release or tagged releases feature. So to summarize, we have a main branch, which is the nightly or latest unstable build. Once we find that the issues meant for a milestone are completed, we create a tagged release with the tag as the version name. And all development basically branches out of master and comes back into master. It is possible for you to branch from a branch of master itself and then do like sub features into that feature branch and then add it back to master through the feature. So that is how the development cycle goes. So this is roughly the whole development cycle. This is not the development cycle that is talked about in here. Here they keep the master itself as only for tags. So master won't contain the latest stable code. It will contain only the tagged releases. There is a separate branch called develop, which contains the latest unstable code. And then you branch out from develop branch to do all your feature additions and so on. So keeping a master separate only for tags and the develop branch only for what we use as master, that seemed like a lot of redundancy, so we did away with that. So, but it's a good read, this one. So if someone wants to read it right away, I can post it in the chat. Okay. So I think this roughly covers the overview of Git, the basics of Git. There is one more session dedicated to the advanced Git practices like packaging and all those. We'll come to that when time comes. So now the first thing that you would need to do is, now you have written code, you're committing, okay, you have a record of what you're doing. Now comes code changes, bugs, and checking if any modifications are breaking your code or not. Okay, so for that, usually what do we do? Like you'll always create a self-consistent check, right? Like you'll either print out the value at, I don't know, temp 1,1. Okay, one obvious check we know is that this is Dirichlet boundary conditions. The value of temperature at the boundary point should not change. If it is set at 80, it should remain 80. So let's do that once. So we have. Wait, where are we? Which branch? There's so many branches. Ah, see, again we would have screwed up. Different report. So we need to be in 1. So that's our code from 4 because it's dead anyway. Get checkout 1. Just see if it's the latest code. Latest code somehow doesn't have that change we made because we made it in main. So let's do one thing. Let's merge our main to 1. Just to update 1. But there's been a lot of changes to main. So we'll again go to merge request. We'll create a new merge request. We'll say that whatever content is there, latest content is there in main, we'll merge into, we'll update 1 with that. Again, there's no closes. As you can see, there's no by default closes main or some issue because there's no issue associated with it. Okay. And you can't delete main branch. That's why there is no delete source branch option here. So we'll create the merge request. Hopefully it won't show any conflicts. And we merge it. Okay. So now if we are in 1 here, oh, right, so we'll delete branch, delete 4 because that's non-existent. So we are in branch 1. Do a git pull to get the latest modifications to 1. There's 1 change. And what is that change? As you can see, it is 10. The bulk temperature is 10. So the bulk temperature is 10. Boundary condition temperature is 80. So we want to print the boundary condition temperature just to make a check that it should remain 80 because it's Dirichlet. And the second thing is you can quickly calculate what would be the theoretical value. Suppose after 20, no, 20 is too long. Let's do it after 1. Okay. Figure it out later. This is one of the temperatures. So, oh, sorry, forgot to make this changes. So line 13, just we change to temp. Something called CFL. CFL is not defined, obviously. So usually what is the CFL we use? We'll use double CFL is 0.1. I think that's too much, but okay. This seems there is a huge problem with our code. Why is it showing this? Basically 0. So now comes debug. Anyone have any idea what is wrong? Let's see. Simplest thing is zero. Okay. Any ideas like why this might be wrong? See, we are doing temp to temp new, and then we are copying temp new back to temp. So the swap is happening correctly here. But why is the boundary condition not picking up the value? I'll make a change. Tell me if that makes sense later on. The way the code is written.
We shouldn't swap the ghost nodes, right?
Yes, or you can initialize the ghost nodes also. In both the arrays. Yeah, means you can either stop swapping the cosines. Yeah, correct. Well, yes, actually that would be much easier. Let's do that. It will be much easier here, but it will fall into a problem later on when we try to optimize things. But okay, for now, you will not swap cosines. That is correct. Okay, nice. I hope the 62 is correct. You can check later. So at least now we know that the code is working fine. Now, usually you would want to make sure that any further changes you make, these values are consistent. Like these are invariant test cases which any modification should pass through, and so on. So the standard C++ way of doing it is just put an assert. Instead of printing, you usually put asserts saying that, okay, this comes from this library called C assert, okay, and you put an assert saying that this is equal to 8p. It's a very, very bad way of doing things, but we'll, for just for 1 minute, we'll assume that this is okay. Let's see if it's passing or not. So, okay, assertion failed because I forgot to put double zeros here. No, it is double zero. This is, I think, the first lesson of precision problems in arithmetic. So when you have double numbers, using an equal to comparison is like a very, very bad thing to do, because one small 10 to the power minus 16 precision overflow here and there, and what was supposed to be a like actually practically the same number, because of this precision overflow or rounding off, it will turn out to be different numbers and so on, and then your assertions will start failing. The standard way to do it, as most of you already do, is take the difference between these values and see if it is less than a certain epsilon. Okay. So it's less than epsilon or something. And usually it's the mod of this value, because it can either be, the difference can be positive or negative. So floating point absolute value. Okay. And for floating point absolute value, I think you need to include CMath, or if you're using STD, I think ABS is also fine. But anyway, we use FABS usually, because in C is like that. Epsilon can be some number which is very small but still meaningful. So let's say ABS is 10 to the power minus 14. Does that solve our problem? Still failing. Why is it failing? That is weird. It printed that 62.008. Let's see. That is extremely weird, right? That might be the problem. Precision issue. No, it's not a precision issue. It keeps failing for some reason. This is how we work. Still can't believe it's a simple thing. Anyone has any clue? I seem to have completely lost. Okay, fine. We'll do it step by step then. Such a simple bug should be easy to resolve. So we will print step by step 62.008, and we'll also print this. Oh, wow. This is some level of rounding off. Very interesting. Okay. This says that there's actually not 62.008. It's much. It's quite different from that. Right now, because we are printing STD C out with a certain precision, it's coming out like that particular value. So we can change the precision of which STD C out prints using your STD precision and all those that you can look up in CPP reference. The precision. Either my net is slow or I'm off the net. What is it? No, this is still on. Okay. Yeah, so you can set your position here, and maybe if you printed it here, you would have seen it is not 62.008, it's some 00739 or something, 793 or something. Okay, so that is done. So at least now we have a R sitting here telling us that any changes we make in the code, we have to pass through these tests to be functionally correct. So this is one way of putting an assert in directly in your code. But if you are going to, run high performance cases production level, one thing is assert can be and is usually deactivated by compiling using -d and debug, because in standard codes and also in the standard C++ library, a lot of these in situ checks are made using assert for debugging purposes. But for production level runs, it is assumed that you have checked the functional correctness of your code, and in the main production run, you're just going to be concerned about performance because anyway functionality has been checked, so that's guaranteed. So then you want to turn off the asserts. You don't want to debug anymore. So the way you do it is, so if we now go to suppose 60, make it 63. Obviously, this is supposed to fail if your asserts are on. Now, if I compile it with -d, so basically ndebug is the flag or macro which says, I'll show you how ndebug is implemented. If you just pass this during compilation and you now run this, it will pass. Basically, what ndebug does is assert internally, the assert function is written like this. This is not exactly how it's written, but functionally it is written like this. So this will just say, take a value, okay, constant, what is my truth? Is it true or false? It will say if truth, then, or if not truth, then basically say P. Error and fail. Some error. This is how it's implemented. Except there is also a macro which says if not defined, or yeah, en debug. So sorry, debug. Then only you use this. Or another way of saying it is if debug, then only do this. Or they have a negative way of saying it is if not defined, not debug, then only you throw an error. So basically now if I use this flag which says no debug, Okay, essentially mdebug means no debug, and this -d is for any C++ compiler macro flag that you want to pass to the main code and so on. So if you pass no debug, it will deactivate all the macros. So all production level codes usually pass mdebug to deactivate all the asserts, and therefore you cannot rely on asserts to always do functional tests if you really wanted to go through every time and so on. Okay, so that's why people have developed their own asserts and so on, which do not deactivate like this. So I would call it, suppose, SS Labs assert or something like that, and use it like almost similarly. It will not get deactivated even if I turn off the debug. Sorry, this is not JavaScript. This is C++.
Sir, so are you making a generalized function which can be called n number of times whenever it is required?
Yes. So yes. So okay, it's lagging. Okay. Okay. I'll just disconnect and join back because we're saying my voice and the screen thing is lagging a bit. Huh? This one.
Yeah.
Okay. Now let's see. Hang around. Is my screen visible? No? Yeah, okay. Fine. And the voice is clear. Like, for example, let's do a test. Right now I'm writing A, B, C, D, E. Fine. Synchronizes? No?
Oh, yeah, it's synchronized.
Okay, fine, thanks. Okay, yeah, so I think as you were mentioning, we are writing a generalized function. So for generalized functions, we'll see how to package them in separate libraries and so on. Right now we are keeping it on the same code, but we can use it elsewhere as well.
Okay, sir.
So yeah, so this is your SS Labs assert, which you can use to run your own unit or testing. As error, which it should. Now if we just change, or you can maybe even say that if truth, then you pass a nice message saying that good job, your test passed. And this is kill. So this is our simple unit tests. Now, usually you would want a better framework to write your unit tests in because these are so common, these kind of assert functions. Writing a general function like SS Labs assert, where you pass a true or false, is nothing. It's just 1, 2, 3 lines only. That's not a big deal. But what different people across the industries have seen is that if instead of just printing the pass or fail, if you can tabulate them and do an analysis on them, or print it out in some report format and so on, then basically your managers can check how many codes you're writing, which failed tests, and which how many failed tests are being corrected over time and so on. So I think Nachiket can give a very nice introduction to what is called regression testing, because when Nachiket was running SoftGen, this Samsung people had made a very nice product. So they were supplying EDA tools, which are basically chip design, like how you design the layout of chips. So, and that requires very, very large number of unit tests, because if one circuit block path fails a particular test, the entire microchip can be short-circuited. So your entire, $10,000 processor will go to waste, essentially. So it's a very, very heavily unit tested kind of code, these EDA tools are. So when Samsung came to them for buying their products, they immediately asked, show me your test logs. And that time, I think they were doing some, rudimentary, not I would say rudimentary, when it comes to what we do, that was very decent and professional. So they were doing some basic unit tests. And then Samsung, these people, they're Korean, right? So they're very, that what perfection thing, that Six Sigma kind of thing, Japanese. So they said that we have done a lot of research on unit testing and the rate of bugs and failures themselves. What we see in the EDA domain is that in the first 6 months of your development work or research and development work, you'll have 60% of your so-called tests should be failing. After 1 year, 30% tests should be failing still. If you are seeing that the tests that the testing team is writing and the development which the development team is doing, these are separate teams, by the way. Like the developer usually doesn't write their own tests in big corporations. There's a testing team and a development team. When the developer is writing code and the testing team is testing for different features in the code, 30% after 1 year, it'll come down to 20%. Over a sustained period of time for 5 years, it will remain at 20%. If these statistics don't match, it means either you're not doing enough testing, or basically it means that you're not doing enough testing or your tests are not written correctly. They were so sure of their statistical surveys across all the companies that they surveyed across, and so or their divisions they were working across. It was like a law for them. For 5 years of company work, you should have 20% tests failing. So if all your tests are passing, it means you don't have enough unit tests, because there will be a test which will fail. There will be a bug in your code. That's the thing. So how do you do this? How do you ensure that you have thousands of tests running every time you do a development? If you have seen sitcoms of IT industry job going on here and there, you might have seen that usually the developer will write 2 or 3 lines and then click compile, and then slowly for half an hour, 1%, 2%, 3% compiling. This is where this whole process comes in, the build and the unit testing. So that is where we will go into. Right now, our build times and compile times, as you can see from our library codes, are less than 3 minutes. For bigger corporations, they go into half an hour and 1 hour and so on. So people sometimes write code to optimize the build time instead of the actual performance. So you can see our build times in our CI/CD pipelines, which will show you the time. So 2 minutes, 3 minutes, 1, and so on. Okay, fine. We'll all come to those things in some time. Those have got the pipelines and stages and CI/CD artifacts and all. So, but let's finish up this unit testing framework. So instead of writing your own test, is there a framework you can use which will quickly tell you, like, and then you have to write your test? Just use a framework which nicely summarizes the results. There are many frameworks, the most popular being Google Test, because Google, as you know, also does C++ coding. It's not just full stack. Actually, majorly, all the so-called web app corporations, the backend is always C or C++, because nothing can beat the performance of C and C++. Even Python is written in C, by the way. So we will try to use a framework. Google Test we can use, but the problem is Google Test is very bulky. You have to download their source code and then compile it, because not every machine you get hands on, you'll be able to do sudo apt-get install Google Test. So you have to build it locally by yourself, and then it's a shared library. So you have to then link the shared libraries to your code and then run it and so on. Instead, there's a very nice testing framework, which is called Catch2. The header-only framework is like Boost. Boost also has testing framework, by the way, but it's again a bit bulky. So Catch2 is a very nice and cute framework. It's a very nice documentation also. It also has why do we need another C++ testing framework, but the tutorial will show you how to basically write tests. So let's quickly see what the syntax is, and then we can start off. So here it says, you mention your test case, give it a name. Forget about this for now. And then instead of assert, you just put require. Require that some function which is written, it has to pass a value equal to 1. Then again require in the test case where it has to pass the value testing and so on. That's it. You have to just write it like that, and we'll see what it does. Okay. So essentially what you'll do is, if you really want to develop, use a testing framework, the first thing is you need to sort of segregate your main core functionality and the actual app that you're building. So how do you segregate your core functionality in this case, for example? So let's say you're going to write a solver. And this is like if you have used GSL library, which is a very simple set of Eulerian time stepping schemes or Rangiputta and all those, you'll see that they usually write a function called driver function, or the solver main solver function, which takes in the data structure of your arrays and all those. So here it will be double star star and double star star for the 2 time arrays. And so or we can get update also if you want it. Update one instead. And just copy paste this whole thing there. So this is how we are just making the function a bit more modular. By the way, why is it? I don't know why there was 4 gap. Again, we'll discuss this on Wednesday, how many gaps to put. And we'll put it via spaces or tabs, but that's a different issue. This is a bit cleaner. If you want, you can also put it in a separate CPP file with a H header. We'll come across all how to build a library. Again, by the way, if everyone knows all these things, then you can just quickly skip and not load this course. Not course means like as in, yeah.
I don't know.
Can you just like wake everyone up?
What?
Can you wake everyone up? So yeah, the update will also contain CFL as this thing. So I'm just making it modular so that writing using the unit tests becomes a bit easier. So and initialization will also be the same kind of. So use this function. So init. ECT. So we'll replace this with can be take bulk. That is correct. And that's it. This should work. So this is a nice idea. So we refactored our code. So first, okay, we almost forgot about Git. All these changes we made. Where is the Git add comment? This is exactly where you should save your code a bit. Git add comment is if you're a video game or PC game enthusiast, it's just like those quick save before you get killed by the demon or something. You can always restart and spawn back at the same place then without having to start the game all over again. So always do a quick save, and this is refactoring to separate functions to push. I think I'll get screwed here, most probably. No, which branch am I in? Oh. And did it pass or not? That's the main question. Oh. What is this guy's problem? 60. Oh God. This is sad. This is a very dirty syntax. I'm hoping this will get rid of that. is this doing all this? Oh, sorry, my bad. Let's see if it should have been there. Let's look for CFL in Git. So as you can see, I don't know, this maybe everyone knows, but double static arrays are apparently not allowed unless you use, okay, wait, use the normal C++. I think it's not. That's it. Anyone can help me out in debugging this? Use them.
Sir, instead of double, I'm not sure if that would work, but instead of double pointer, if you pass single pointer and do that cross, then brackets.
So there's a single pointer.
Yeah, single pointer and then
Bracket.
open square bracket, close square bracket, and then 12.
Oh, you mean your past 12 also? But that should be auto-reduced, no? Or it's not?
I'm not sure, but is it 2D array, right?
Yeah.
So this one should work. I hope.
Yeah.
I'm not sure though.
Okay. We'll do, okay, this is not the problem we want to discuss right now. So we'll do a very bad cheating where we will just make it global. This sucks like anything, but we'll come to C++ problems in tomorrow's session. There is some very stupid mistake going on here, but what to do?
No, not that 12. उसको वैसे ही रखो खाली and आगे 12 index, I guess.
You mean like this? No.
Oh yeah, first वाला खाली रखना है and
Like this? Okay, maybe this will work. I don't know. I remember falling. See, the problem is since we don't use static arrays, multi-dimensional static arrays so much, I've forgotten the syntax of this.
yeah, this one. There is lag, so I'm not able to.
Yeah, okay. Oh, there is lag. Okay, fine. So fine, let's try this then. Wow. Okay, that's fantastic. Like this is like C++ is saying lol or cut. Nice. So great. So we will compile this. We have refactored the code, and now we will see how to use unit testing frameworks, because as we discussed, you can't keep writing your SSLabs, etc., so on, and just print out pass or fail. Initially, we used to do this. Print it out on screen and then count how many grep for a number of pass and WC minus L. That is not a very nice way of doing things, apparently, as we have been asked not to do that. So how do you use catch, for example? So the first thing we'll do is we'll go to catch's website. It's a header-only file. They will tell you that, okay, you'll see a lot of other. For some reason, the office internet is very slow today. I don't know why.
A lot of lag.
Yeah. Maybe tomorrow I'll do it from my home itself. Okay. So basically the main file that you need to use from catch is hidden somewhere. There's so much data. The actual file is just one single file. Catch.html. Okay. So what we'll do is we'll quickly clone this repo and then extract, or we can download that single file also, but okay, let's just clone that. So oh yeah, no, this is going to be a huge repo. Yeah, okay. So we will just copy the main file, which is in source, and this catch2, and then this catch all. We'll copy it into, suppose, our terminal repo itself for now. We'll see how to structure all our codes and so on. Certain way. Yeah, let's look at the documentation also. Keep it handy. what we do while writing our test code. So, okay, just before that, this is your main code, right? So this is supposed to form the app that you give the clients, and your test code is supposed to be a bit like separate. So you don't give your test code also to the client because they won't have any use for that, because they won't know. Usually your code is proprietary and hidden and compiled to a binary. And even if they see that these many are passed and these many are failed, they won't be able to do anything useful with it apart from complaining to their managers that this vendor sucks at giving software or something. So what we'll do is we'll just split up these functions into library files and the main app file and a test file also. So what the basic library will contain the init function, the update function, and SSLab assert can also be a separate library, but we'll put in the same library. So we'll just create solver.cpp, put all our functions there using, which is assert. We are not using CAssert right now, that's fine. We're using CMath in the main, not everywhere. So we'll just copy these things and put them in a solver.cpp. And this is our main or app.cpp. So main is usually, so this is the app that will go to the client. And if this is the app.
Samidip, so
Yeah.
what is the difference between this and the unit test that we write in CMake thing, that test folder?
Oh, that is also, okay. So CMake test will allow you to run tests, but what you write is again, means you have to write something like this using asserts and so on. CMake will just run those. So basically whatever files you declare as test files, when you type in make test, CMake will run those files only. Okay. So CMake doesn't, what do you say? CMake will not be able to write tests for you.
Understood. Okay. Yeah. Just runs whatever.
It just runs. Yeah. Whatever you define as tests. Yeah. As opposed to non-test files or production level code files.
Okay. Thanks.
So let's call this
testing framework that helps us write tests.
Catch2 is the testing framework that helps you write tests. Yes.
Okay. Thanks.
We'll same like Google Test, or there are multiple other test frameworks. Yeah. So you can choose any of those. So tests will contain the test values or test cases. So we will just create this test. So again, you have a test case like this. Init run. So these are your test cases. What is the difference between app and this? In app, you don't do all this asset business. In app, you just print out the final value which the client wants. This is basically conceptually the difference between your app and your tests. And now, if you want to make your app.cpp, you'll do this. It says I can't find init and update. So basically, it doesn't know where to look for this init or update. That's why you have to give it a interface file. So basically, whatever you wrote in solver.cpp, you have to just take out the signatures and create a .hpp file out of it, or .h or .hpp. Again, assert should this SSLab assert should have its own testing library by itself, but right now we're just quickly trying to do it, and so we'll put it in. So this is how you're going to create the interface or the header signatures of these functions, the declarations of these functions. And usually you might have used a guard, like if and if something solver h, then hash define solver h, just so that this declarations don't get included multiple times, otherwise it will lead to conflict. Like the compiler will think you're creating different functions with the same signature, which is not allowed in C++. So this is how you do header guard. But usually, and then You see people doing this also, just comment out what is it. There's a lot of redundancy. So nowadays, most compilers support this thing, hash pragma once. So just use hash pragma once. That's the same thing.
So what is hash pragma once like?
So have you used something like this in your header files previously?
No, I just saw this once.
Okay. So essentially, if I have to show you why this is needed, so suppose we wrote a header file. Actually, if we just leave the header file like this, no, okay, let's leave it. When the problem comes, it will automatically find out what error it shows. So okay, let's assume the header file can be written like this. We'll come to hash there once the actual problem starts showing up. I don't think we include anything. Everything is standard C data type, primitive data type. So it's fine. This is your header file. Okay. So HTTP. Okay. So now you have to do your G++ app, and you should tell that the header file is to also include. Sorry. To include the signature here, otherwise it will start complaining. So you can get solver.hpp. And what was the error to you? Oh, we don't have a main function anyway. Why is solver passing something like this? Oh, okay. Yeah, we are using stdc out, so definitely we need to. Nice. The reason is that this is a library file. Like this is not a main file. There is no main function here. That's why you can't just do G++. You can compile it into a library. We'll come to that, I think, in the next packaging section, to compile library files and all those. So for now, you can just do GCC. This is your app. And your dependencies on this solver.cpp. Okay. So this is how you compile your app file, and the other way you compile your test file is very similar. Also, the test file also you have to note down all the dependencies. So
sorry to interrupt. What is this .hpp file extension?
Okay, so when you wrote the single monolithic main.cpp file, all the functions were there in the single file. Right?
Yeah.
Now we are trying to make our code a bit modular in the sense that we want to segregate the solver functionality. Later on, we'll segregate inside solver. We'll segregate the update condition, the boundary condition, and all those. We'll make each file small and small, so it's manageable. Like, and we know exactly which function is where. Because if we create a single file with 1,000 lines or 2,000 lines, it will be very difficult to read the code and understand what is it, where are the dependencies, and find bugs and so on. Okay. So, and the second thing, advantage of splitting the code into multiple files is that apart from the file which calls main function, every other file can be converted into a library. So why do you need a library? Well, apart from a lot of other reasons, if you're in a private or industry, the main reason is you want to hide your source code. So you don't want people using your software to actually know what you wrote in the software, because otherwise they have to pay a lot of amount to acquire that IP. Okay. So so you want to hide your files. If you just compile your main.cpp, a single 1,000-line main.cpp, and give them the binary, that's fine. Okay, you can hide your IP using just binary. But sometimes the client will want only functionalities in the form of library, and they want to write their main.cpp using your libraries. They don't want a binary. They will create their own binaries. Like, for example, take C++ itself. See, when you are calling these IOStream and CMath, essentially you are using C++ standard library functions. Okay. Now, if CMath or the equivalent of that in CPP, like math.c or math.cpp, if something like that existed, if that had a main function by itself, you wouldn't be able to call this library into your main, because there would be two main functions and the compiler will get confused, which is the actual code. Okay, so libraries are always those portions of the code which don't have the main function, essentially. Okay, they contain functions which can be called on into other codes without actually running by themselves. So when you are writing libraries like this, you can define your functions in separate, like solver.cpp files. But as you saw, if I don't use a header file, this app.cpp file won't know where these init and update functions reside. Like if I just do g++ app.cpp, it will say undefined reference to this init and undefined reference to update. Okay, it basically means that if you really want to go into the depths of it, it will take some nice 2-3 hours. But if you really look at the okay, we'll come to it when we actually compile the library. You can see exactly what the code is trying to, or what the compiler is trying to say to you by throwing these errors. So essentially what it does is the function calls in your app.cpp, they are expecting some function of the signature. Now, where is this function, essentially? You can also pass, if you do not have the HPP file, and if you just passed on the app.cpp alongside this thing, it won't compile. Okay, because again, it will say that I am seeing some function like this, but it was not declared. Okay, so it will throw weird errors. So there are two different types of errors you're seeing. It basically means that although the compiler is able to see some signature of the functions in this app.cpp, it's not very sure. Like basically you have to tell them what the signatures are of your functions that you're looking for and where you can find them. So the way you do it is for every other library file that you write, source file that you write, you usually just put the signatures, like the user API. It's like the user manual that you're giving to the compiler, that this is what the user should be able to use as a library. And so that's why if you just give people the header files or .hpp or .h files, it is almost as good as a documentation in the technical sense. It's like the interface file or the API file and so on. And the actual implementation is in the solver.cpp. So that's why you need to have a documentation. So this is what C is basically saying. Without a documentation, I won't try to find, or I don't know what the function is doing, or what the function requires, and so on. Give me the documentation. So you give the documentation by giving the header file or the interface file. So that's why we need this HPP. Ideally, this is not the correct syntax. Ideally, you should say that I should include the location of the header file as well. So it will be like this. And you can then write it as this itself. So yeah, so we were trying to, the reason why we came through all these things is because we were trying to separate out test cases like this. So now we are compiling our test CPP, and if we do a.out, it's passed and passed. Okay. And if we do our app thing, it will say the actual value, right? Yeah, okay. So now, if you want to use your, just before that, just give me one more minute, I'll just show you. So usually header files go, there's a standard hierarchy of folder structures that most C++ codes maintain. All your library or internal implementations go into a folder called the source code, which is src. So in this case, your internal implementation for the library functions are solver.cpp. So you'll move your solver.cpp to inside src. Okay. Your interface documentation or in-code documentation, which is also known as the header file or the interface file, that goes into include. So you'll create a folder called include and you'll push your documentation there. Code documentation or code level documentation, code like documentation. documentation. Yeah. So, and there's a folder called tests, which usually contains all the test cases. So your tests will go into tests. Usually inside tests, you don't just call it test, you call it what it is trying to test. So there's a test update maybe, or init. So you can write multiple test cases. Actually, let's do that. We should write multiple test cases. Like there is a test update, and before that, you first want to see the init function is still working. So what will init contain? So init should say that forget about this update. I just want to see if I call the initialize function, it actually initializes correctly. So if this is the case, then this should be 10, right? By the way, this is also a double. So technically, we shouldn't be doing equal to. Something like this. Is there a okay? Nice. Okay. So this should be the test case for testing init, and that should be the test update case. Okay. Basically, once you've tested init, you need not. Okay, fine. Let's keep it like that. This is the folder hierarchy, and now you have your main app.cpp. You can either put app.cpp in the src folder itself, but usually nowadays when we create libraries, we keep the library function separate and the app which uses it, we put it in app or something. But it depends on you completely. Like, okay, if you don't like the modern syntax of app, everything was used to be a source code at one point of time, and move app.cpp into src. Okay, so if you now look at the hierarchy, forget about the catch-all right now. It's include, readme, src tests. This is a very nice folder hierarchy. What we quickly do is we catch outside, and we comment this as a good example of how to write code or how to structure code. So git commit minus am refactor. So now this part, oh sorry, things. This part, we were using the SSLabs assert. Now we're going to use catch2 and see how it simplifies our thing. So one thing is, instead of main, let me break it down a little more. So let's call this as test1. Inside test1, we'll call this, so that you can have multiple test cases to check things. So this is one test case, so you'll be calling test1 like this. Test2 can be, suppose you initialize with a different value, just to check if your initialization is working for all different types of values, some different types of values. So test2 can be, suppose I put 100 here and 50, and this should also give me 150. And so this is how you write your code, and if you compile, it will be test init cpp. This is the main file. Now you have to also include your source, which is right now sitting inside solver. It says solver.hpp not found. First, we will quickly do something. We'll provide the location of where the header file is using -i. Okay. What failed? Right, something failed. It have failed. That is weird. Any idea what failed where? And by the way, why are there 3 things? There should be 4 test cases. What's the problem? This is that is fine. Okay, this is fine here, it will fail in this thing also. So we'll quickly try to debug this once. Let's see where it's failing. So worst we have debugging, but this is the most practical way. second case is failing at the start itself. That is very interesting. Did you hard code the values? I think that is what happened. Very nice. See, this is why unit tests are so important. Let's see if that is the case actually. Yes, we did hard code the values. See, if we had not written the unit test, we would have completely overseen this. Did someone see this when we were writing the code? Then they should become a unit test framework themselves. So this is how you compile your code and you run your tests fast. Beautiful. So as previously we were saying, this is the most ridiculous way to check how many tests are passing and failing. We used to do this at one point of time, but now we don't because of professionalism and all those things. So how do you write how do you write your test cases using a nice test framework? If you really want to go one level further, what you can do is you can take down your main driver file. So essentially, see what is happening is, okay, this will basically tell you why we need frameworks. Right now, there's test init, which is testing two different cases of initialization. You have test update also. So if you want to test the initialization cases, you have to compile the test init, right? And then run it and so on. Then now you have to go to test update also, and then compile it separately and run update, test update, and so on. So instead of running and compiling and running these test cases separately, it will be nice if you have a log or a table of all test cases at one shot that are passing and failing, instead of breaking them down up by these kind of cases. Again, if your project really demands that kind of a broken method, you can go ahead with that. But usually what we see is when you're compiling a library and testing out a big library, it's always better if you write multiple test cases, but finally when you're testing or creating test report, all of them are summarized in the same one, essentially. So the way you do it is you create a main test.cpp. So essentially you'll take your main function from test.cpp and put it here. So it's the same thing, like inside test itself, you're breaking it up into an app file, a test app, and the actual library functions for the test that you're going to call. So this will be test init case 2 and test init case 1. Like this. This is supposed to be the library functions. And you don't need IOStream, you do need solver.hpp, math also you need. Okay. And similarly, what you can do now is you can remove the main from test update.cpp and instead call this test update case 1. Or you can return anything. It means you print out directly there if it fails or not. Or suppose you don't want to make it fail or exit the code when you see it's failing, you just print failed and then continue with the next test case. That also we can do. So what we'll do here is we have these two, test update and test init, and we have a separate test.cpp file. As we did before, what we need to do is we need to create a header file also, because test.cpp, if we just compile it like this, won't be able to pick up images. Okay, where are these? Okay, yeah, minus I is required anyway. It says where test is anyway not defined. We'll change that. Test init. Yes, one. So these are not defined. So what we do is we'll create the header files. So you'll have test init.hpp. So now you can see how slowly it is becoming tedious and redundant. Like for every test case you create, you'll have to have a CPP and a HPP file separately with the signatures. Or you could write one big test case where all the tests are there. But again, as we discussed, it's always better to break up your code into small. Usually the rule of thumb in nowadays coding file guides is each file should not contain more than 200 lines of code. Why 200? Why not 210? Don't ask me, but it's roughly ballpark number. Oh, this is init. So yeah, technically you can put this here. So we'll need to create another, and this won't work. But, oh, this will work. That's fine. So this .hpp. All this pain that you're going through right now of seeing this really boring stuff, the more pain you feel now, the better you'll appreciate Catch 2. Okay. So now we can happily do yeah. You have to include the signature here. Yes, it won't find it. So test init.hpp and also include test update. Email documentation. Saying where is test input this thing. So basically you have to include this folder also because the test init is here. Or what you could do is inside this itself you could go into include an SRC, but usually we will skip that. I'll show you quickly why. So it says undefined because we didn't include the other ones because we haven't compiled them into a library. So we'll quickly include the SRC one also, which is solver. So you can see how big so you can imagine if you have thousands of test cases, you'll have to include thousands of files like this. So we'll soon see how we get over that. Just run this and see how it looks. Good. So I think we'll have 6 test cases passed. Okay. Now we'll see how to quickly replace it with Catch 2. So in Catch 2, what we do is we will delete all the .hpp files because those are not required. Okay, let's first use Catch 2. Let's first comment this. Always comment your code when there's a big change. Its status. So you can see there are these many files which are going to be commented. Why is include an SRC also new? Did we not commit them last time? Which branch am I in? Yeah, weird. Did a refactor commit? No, wait. What happened? Suddenly my account gone missing. It did, but it was not registered. So weird. Okay, so git add status and git commit -em. So refactor. Okay, include tests. Now we can use Catch. So we just downloaded and kept Catch aside. We'll now bring it in here. With Catch, you'll have a test.cpp file, but you don't have to write your own main because Catch will do its own internal stuff for listing out and calculating all the test case results. So let Catch define its own main. That's why it says #define catch config main. This is like Catch. So essentially, it's something like this. So Catch internally in the library has defined something like #define catch main is this kind of a like code. I know it looks weird, but and then it has done some template magic, how to list whatever things you send to it and so on. Okay. So they're saying don't define your own main, just include define catch config main. That itself will be sufficient to declare a main function. And after that, do a catch include catch HPP. So we'll do that. Include catch HPP. And then they're saying, okay, you can put your functions and whatever. So we are going to use our test updates here. So this is usually our test file, main test file, and that's it. This is usually your main test file. Now in the actual test cases, we are going to write these test cases again using catch framework. Catch's framework is, don't define all these functions like this, just call them test case. We called it init case 1, right? So just use normal human readable language instead of all this camel snake case. You can see they're right. This is a separate thing called a subsection of the test. We'll come to that. There are actually different ways of writing tests. There's a test behavior-driven development, there's test-driven development, and all these have like you can write tests in a mathematical form, proof or theorem syntax, like assuming this and this, if this condition is met, then this should hold true. Like this, you can nicely write sequence your functions and conditions and so on. We'll use them when it's needed, not right now. Right now it's very simple, just put requires and stuff. That's it. Now you don't have to even use or define GitLab assert or a separate test library like that.
Sir, I didn't understand one thing. Why you are doing this in 2 loops? Like ये दोनों एक ही loop में नहीं हो सकता? Considering it as a single case.
Yes, you can. Why? No, this is, you can do it. Yes, absolutely. One thing is, well, you are saying that I do initialization at 150 once, then test for that, and then again copy paste this in the same test case and do it again, huh?
Yeah, so.
And delete it. Yeah, okay. So you can. I am just breaking it up because, sorry. When you see the test report, no, you should see the test report. This is just an example, first of all. If you really want to do that, you can do that. It's not an issue. The number of tests or required conditions will still remain the same. It's just that if the second case fails, then it will show that init case 2 failed, init case 1 passed. Okay, it's more like it's aesthetics basically, nothing else. Like how modular you make your tests. Like
so it would be easy to debug if case 2 not open.
Yeah. Okay. So, but since the initial parts, or as you keep writing tests, you'll see that across many tests, the initial setting up part of the test case is very common or repeated. There are ways to handle that also. Like you do one setup and then you write multiple test cases for the same setup and so on. So those are, again, we'll cover as and when, if it is required. Otherwise, once you know the basics, you can read documentation and do it yourself also. The basics are all that much. So you write a test case like this, and you can do away with your headers. So we'll delete the HPP now. Similarly, for test update. Oh, sorry. Oh, by the way, since we are using catch syntax, we have to include the catch header also. So how do you do that? It says do it using catch.hpp. So we'll include catch.hpp. When you're organizing header files in your library, who is the originator of the C++ language, suggests that you put your own library functions first, then you put third-party standard C++ library functions, like catch is a third party, but a non-standard C++ library function. Then you put C++ standard library functions or libraries. Okay. If you want, you can follow it. If you don't want, don't follow it. It's just a convention. And if now if I was doing IOStream, which is also a standard C++ library function, inside that you can do alphabetically. That's not an issue. It's within that sequence. So here we will again quickly go to test case. It's okay, this one. And we will delete the HPP because there's no function that we have defined. Now it looks a bit cleaner. you have one header file for the test cases, one main test file, and then your small test cases. So now you can just keep writing your CPP without redundantly adding a HPP also. So now you compile. Hope it compiles. Okay, we had the compilation somewhere. Where did it go? This is the problem of up, huh? Compile it. I don't know. Let's try. Okay. Oh, test.cpp. Oh, yeah. We downloaded catch all.hpp. This is supposed to be renamed as catch.hpp. Wait, is this wrong code? There's a nice single file which is usually there. Which one is that? Or we can download from our own repos. We usually have that. Still, huh? Okay, fine. Just leave this for now. I don't know what changed this. Oh, okay, okay. Fine, forget this for now. We'll just take the catch library, which we usually use. For their current repo, I'll tell you what to use. It's a huge file. We'll quickly download it. Download. Okay. So we will delete this catch. Use the catch that we recently done. You can see it. This is what build time looks like. It's building, but compiling, because a header-only library is very, very bulky for the compiler. Okay, sorry, there's a test case syntax error here. Just test it. Syntax. Oops. I'll quickly look up my own codes once. It's correct. Oh, that's supposed to be correct only. As you can see, we have forgotten to include our header file. That's why it's complaining of weird. Okay. Yeah, okay. You can see like our build time already went up to what, 30 seconds or something like that. Soon it will keep going up till one day you will become a professional developer and your build times will be 10 minutes, 20 minutes. Now if we run a.out, see, first of all, you have a nice color scheme. Secondly, you are equipped with a lot of automatic, report conversions and so on. So you can change the reporters, you can change the orders, and actually show the outputs, what happened, then do a micro benchmark of timings also, and then there are a lot of options. We'll slowly go through them. Otherwise, I'll recommend a very nice video which these catch people gave at a UK conference. It's again there in the systems repo if you want, but I'll just mention the okay, I'll mention it separately. It will be somewhere. Oh, it's usually where is the workflow? It is usually given in this older version of the sample project workflow that we did. So you can find here modern testing with catch, a nice video tutorial. I'll just post in the comment here. There's a nice, just a nice weekend watch if you don't have any Netflix movies to watch. So yeah, we can change the reporter and let's list reporters first. See its compact console JUnit. So we will go to reporters and just 1 minute. Oh. You can play around with the different styles. I think JUnit gives you, we'll use this JUnit reporter style to create nice GitLab pipelines at a later stage. I think, yeah, this is fine. And then you can also print for if the tests passed also. So abort after X number of failures and success. Yeah. So we'll use console and you'll use success. Okay, now you can see this is what we're talking about. So in test case 1, it shows what was the test, what passed. So the difference was 0.01. The requirement was 0.01 and the pass was 0 and so on. Okay. So this is how the full-blown test output looks like. And then you can tabulate them also. A very popular other unit test framework is Google Test. Example, if you go to output, you will see how their output looks like. Great. It gives code samples. I want output samples. Okay, there is a YouTube video, so you have it there. I think there will be an output. But anyway, so basically these frameworks tabulate how many are passing, how many are failing, and like this, essentially, if you can see, it will. Here also you'll use expect equal to, assert equal to, and so on, and it will show which tests are running and which are failing, and so on, like this. Okay. So it depends on your choice. Here we prefer to use catch because it's less bulky and a single file. And regarding which file it is, I'll just update you once after the session. They've been using older version, which is a single file. I think they have made some changes in the new catch version release. So we'll find out what the changes are. Yeah, so this is unit testing with catch. And what are the other topics that are supposed to be in the catch part? So JUnit test reports will come to at a later stage. Build, now CMake. So before that, are there any questions regarding tests? So just get comment. Good. No questions? No, nothing. Okay. So usually when you include third-party tools in your folder, there might be licensing issues and so on. We'll come to those. So for example, I nicely put catch here, which I should not have done. I should have been more careful. I think it is distributed across Boost, so Boost is more liberal. That way it's fine. But usually we make a folder called vendor. If it's LGPL or GPL, like stay away from committing it in the same repo. Otherwise, your entire company will go down by some person suing you. Otherwise, if it's okay to distribute the code within your source, you just put it in a vendor or inside or outside the test folder and so on. So we'll just add this also. If that is the case, your compilation commands have to change a bit. You'll hash include, or not hash include, yeah. You'll -i include from vendor folder also. Okay. So these are the tests. and then we have CMake. Now, as I understand, it's 3:51, and we were supposed to finish all of these things by 4. What should we do? Obviously, CMake won't finish by in next 8 minutes. CMake is quite heavier than catch too. So let's do one thing. Let's stop here. I would like to take some feedback on timings, space of this session was, I think, mostly one way. I don't know, is it because it's after lunch, everyone is like very sleepy, and it's nice weather also, at least in Bangalore it's very nice weather. But is it okay, should we speed up things a bit, because I think most of the second part of the code many people know about already. So when we go to CMake and this CI pipeline stages artifacts, should I just quickly like run over them, or should we go at this pace only? Is it okay? See, if the only thing is, if we go at this pace, it will take 7 days instead of the 3.5 days, because okay.
I think for unit test, this speed was fine because at least, I mean, I don't know, I think many others did not.
Okay.
I mean, also, I don't know, but yeah, maybe.
CMake, what about CMake? Like, should we maintain this? Yeah.
So
Yeah.
is it recording it?
Yes, it is being. Why? Like, you don't want to interact?
No. I am asking if, like, even if you go fast, then it's fine. We can just go back, even if you miss few things. Like, if you don't understand few things, we can go back and check. And also, you can, like, let's say right now you shared one YouTube link. So you similarly if you want people to go deeper on their own, you can just share if you links are available like this. That.
See, the plan is, after this discussion is over, these audit people are already on people's heads. Like, implement the policies right now, everyone should be following. So the thing is, I'll go at a pace where suppose next week onwards, everyone will be able to start using GitLab like, real pros. The audit people will come and say, wow, what happened last week? Okay, so it should be like that level. Okay, so if we can decide on some pace which is suitable for everyone to start using GitLab and this unit tests and build and all those things, then we can increase the pace. Yeah. So again,
I think it depends on audience. No, not everybody
exactly.
use. See, for example, we have been using Git, CMake, although we don't know that much, but at least we could kind of follow whatever you.
Okay. So where is all the other audience? Like, we need to take feedback. Okay, people who think it is too fast, can you please comment, slow down in the comments? Then we'll have a vote basically. Or if you think it is too slow, say, okay, speed up. And if this is the correct pace, I really don't think this is the correct pace. It's because Nachiket was in the office today. He mentioned that I told him it was scheduled for 3.5 days. The pace at which I'm missing the timings, this can go up to 7 days. So he was asking how much of regular work will get affected by that. So yeah. So basically, okay, fine. What we can do is we can take maybe till Thursday evening session, and if okay, fine, you can take Thursday evening, Friday morning maybe. There's basically 2 more sessions we can add. By the way, there is one requirement we were discussing. Is Chachu here for no, Chachu's not here. Okay. So what Jaju was mentioning, he reminded me that I forgot to put in Python scripting, like not Python scripting as in Python, the code itself, how to create Python interfaces for C codes. Will that be something anyone is interested in learning? If there is enough demand for that, I'll add that module also.
Yeah, that would be good.
That will be good. Okay.
Yes,
because see,
that'll
be good. Okay, fine. Yeah. Then see, Python wrappers on top of C code is the flavor of the day. Okay, starting everything from TensorFlow to Flask to most development, like most so-called popular Python packages are actually Python wrappers on top of C codes. Okay, so if that we know how to do, it's actually, we'll not do it ourselves. You can do it yourself. It's a very tedious way of doing things. We'll be using Boost or PyBind 11. We are using it in production for Shinko. And we plan to use the same thing for all scripting purposes. Usually, the gaming community uses Lua as their scripting language of choice on top of C++ real game rendering engines, game engines and rendering engines. In the scientific community, people prefer to use Python as the scripting language on top of C simulation engines. Okay, so we'll do that then. You can also do JavaScript on top of C or Java itself also. So all these combinations are there. So if you know one INI scripting also. Okay, so by INI you would mean Boost options, right? Because if you, that is a standardized INI file. So by INI versus Python. Okay, fine. We'll go through Boost options also. Okay, so like this, if we include Python scripting and INI also, it will easily take one session. Okay, so we'll put that on Thursday afternoon maybe. That was a free slot. And the second thing he asked was, since we are going to do a lot of documentation work in Doxygen and Sphinx, and maybe update your own case studies on the website, we will cover a bit of how to upload on pkgs.syntheslabs.org, basically how to create a simple tarball and place it in the public _HTML folder that is being served at that IP address. But would you like just the basics of HTML, CSS, and JavaScript so that you can at least know how to modify a given static web page? I'm not saying develop your own web app using the server client and all those things.
Yeah, I'm okay.
Okay. How many?
JavaScript I don't know.
Can you repeat once more?
Hello.
Can you repeat once more what you said last?
No, I know HTML and CSS, but I don't know JavaScript.
Okay, so basically, if you cover Python, it's almost like conceptually, it's very similar to C++ and JavaScript, but the syntax is a bit different and implementations are a bit different. But okay, fine. Means the logic will be the same. It's the same if else condition, for loop, and what function calls. That's it in any programming language. So that's it. Okay, fine. So basically, if we include these two modules also, if people are interested, I'm not saying HTML is required for everyone. Oh, by the way, as we discussed, if anyone is feeling bored or thinks this is already covered, means they already know the stuff that is being covered, you can drop off for these modules. Like there's full scope of selecting which modules to attend individually and so on. There's not like everyone has to attend every module and things like that. Okay. So if there is sufficient interest, then we can add that part also. So then it will basically extend to Friday, minimum. Okay, so fine. Then we will continue with this discussion maybe tomorrow. I think in the end we will end up with the where was the SSLab score part? We'll end up with seeing how to use the core library on Thursday or Friday. Basically Tuesday, Wednesday we'll go into this workflow and optimization, MPI, OpenMPI. By the way, a quick vote again. How many of you think optimization, or first of all, parallelization using OpenMP and MPI should be discussed at all or not discussed?
Hey, we have to discuss. I think I once messaged you. Yeah, that's
Okay.
something that I would like to.
Okay, fine. Okay.
I mean, I don't know. It depends on you guys also. So in the sense like, especially the way in which those blocks and basically the grid that you guys are.
Yeah.
You guys have written that basically that.
Okay, fine.
Sir, is it possible to add that SIMD vectorization and all those portion?
Okay, fine. Vectorization is one session. Is anyone else interested in SIMD and vectorization?
Yeah.
Okay, fine. Then this will go into Monday. Nachikeet is not going to like that at all. Today he was not very happy when he said. Huh?
The list is growing.
Yeah. No, it's fun. Basically, you know what he'll say? He'll say, do this in your own time. Do it either on the weekends or after 7 o'clock in the evening.
No, you want to split this or something for next week little bit and Because
We
it'd
can do
be
that.
too
We
much
can-
for
Yeah, you can do that. Yeah.
too much for you also. Or
Okay.
Yeah, Sumit, you can do that. So whatever that is necessary, for us to follow the procedure,
Yeah.
that you can cover, and other advanced topics you can cover maybe, like after, yeah, in the evenings, like maybe after
Weekends,
7 or weekends.
Okay.
maybe 2 days a week, every week, something like that.
yeah.
Acha. Okay. Okay. Fine. Then I'll chalk out a alternate schedule and circulate it. Maybe Madhushri will take a vote. Is Madhushri here, by the way? She said she'll drop in. She dropped in the morning, but she's not here right now. Okay.
She was here, I think. Maybe she got.
Okay, fine. Yeah. So as long as we are on the topic of discussing new topics or more advanced topics, is there anyone who would like to learn general relativity or string theory also?
Why are you enticing people, man? Why are you enticing people, man?
Okay, fine. Okay, fine.
Yeah, I mean, sure. I mean, that would be nice. Something. I don't want to like miss this question.
I think
So have you worked on that?
additional
Worked on
material.
that Alcubierre algorithm? I would have interested in that.
Which algorithm?
That Alcubierre algorithm where you do a 4+1 decomposition of the space-time field for solving the Einstein's equation numerically.
What is
Who
the name?
has that faster than the speed of light metric? Alcubierre metric.
Oh, I don't know about this. Okay. Yeah. No, this is way off my.
Like one, I have. Okay, so
Okay. Fine. No,
any algorithm regarding that.
So usually in general relativity or numerical relativity nowadays, the most popular algorithm of choice is dynamical triangulations, both for classical general relativity and quantum gravity. What it does is basically makes an STL patch out. It basically makes an STL mesh, a 4-dimensional STL mesh to be precise, and then it changes the skewness or distance between vertices of a triangle to represent the speed of light or morphing of space thing. Okay, so if we go into that, that is basically going to be an extension of STL parsing itself or STL modification. So we can add it to STL to marker also. Just that we need a 4D grid instead of 3D.
That skewness thing, is it in real time, like dynamic, or how does this work? As in
No, so
stretching?
basically you have an upper limit to the skewness of a triangle, which represents your slice in space-time, because the diagonal of if you think of it as a square, will basically represent the maximum distance anything can travel if it travels at the speed of light. So that's like an upper limit. So that is the longest, that is the hypotenuse essentially of a triangle. And if anything is traveling only in space, it will be one of the perpendicular edges. And if anything is traveling only in time, it will be in, or basically staying at a place. Okay, anyway, yeah. These are very interesting topics, but yeah, if we discuss this, like.
I think that will be discussed.
Yeah.
Maybe Broad or Watson or some other place.
Fine. Sure. Fine, then I'll circulate a modified timetable and then we'll see how to proceed. For now, then are you suggesting we should do it only 2 days a week? Is that okay with
That's up to
everyone?
you. Yeah.
I think for this session, we should finish. I think whatever that are required is to like smoothly work with Git flow. I mean this.
Okay, fine.
All the process that is required for us to follow.
Yeah. Okay, fine.
Topics you can cover.
Fine. Then I'll circulate the modified timetable. Yeah. Okay. Any other questions, suggestions? Anyone?
Sir, I had one basic question.
Yeah.
So when you do git pull and git push, so using that GitLab, there is like fancy GUI.
Yes.
But when we do git pull, how are we going to track it on our local machine, the changes, using GUI or something else? Is it possible?
You want to track it using GUI or command line on your local machine?
GUI, it would be like easy now.
Okay. I think there are packages which let you do GUI visualization locally on your desktop or laptop. We haven't used it.
This thing, desktop app, I think.
GitHub has, but this is GitLab, no? It won't work with that. So, see, okay, Radhika, one thing is, if you are going to just do a git pull, only the content which is relevant to Git as a protocol itself will get downloaded. Issues, milestones, comments on the boxes, on the code and so on, diffs, those are not features of Git as a protocol or as a framework. It is a wrapper or a decoration given by GitLab on top of the Git framework. So if you just do a git pull, that is from your laptop, that is pure Git at work, not GitLab. So only the features which are available in Git as a protocol will get downloaded. That is basically issues are not there. Commit messages, commit summaries, your commit history, branches, merge requests or merges, and so on. So there's a very restricted set of utilities which Git itself provides. Everything else is, tomorrow maybe we'll cover a lot of things like Docker containers and these pipelines and so on. All these are GitLab decorations. Okay, these will never get downloaded by doing a git pull onto your machine. You have to do it separately.
Sir, and using command line, how we can track the changes when we do git pull?
So usually when you do git pull, you'll already get a plus minus symbol diff, like these many lines were added, this many lines were different. There is something called a git diff command. If you're changing code and if you issue this command called git diff, or I think you have to first commit and then do git diff, then it will show you the difference between the last commit and this commit, or the current code also. Similarly, if you are trying to do merge conflict resolution on the terminal by yourself, git merge tool is there. So basically, okay, then tomorrow when we are doing Git, we'll try to use a few of the command line syntax itself instead of using the GitLab GUI. And yeah, just remind me whenever you see me reaching out for some GitLab UI feature, ask, can you do it in Git directly? Okay.
Okay, sir.
Then I'll remember how to.
Thank you, sir.
Yeah. But I also don't know many of the, like I know almost nothing of the Git command line. So I'll also have to do a Google search and find out. Okay. Okay. Anything else? No one? Sundaraj, any comments? How is the pace? Is it okay? This is there. No, okay. Okay then, fine. We'll call it a day today.